Lesson 5.3.1 Formal Reasoning in Euclidean Geometry continues. In this video, we will be completing truth tables. Truth value. Truth value of a conditional statement is whether the statement is true or false. Truth table is a table that summarizes all the possible truth values of a conditional statement. P implies Q. Complete the truth table for the given statement. Okay, 5 says if the measure of angle, the measure of side AB is equal to 6 and the measure of side BC is equal to 6, then side AB is congruent to side BC. So when we do truth statements, fill out the truth table, we have to identify a few things. So we always look at, in the first box here, this being T for truth. Okay, so what does it mean that the measure of AB equals 6 and the measure of BC equals 6? It means exactly what it says. It means that those are those numbers. Okay, and we're saying that that's true. Then we look at the second box and we say a T in this. We're going to make the assumption that this is true. So the measure of AB, or angle side AB, is congruent to side BC. Okay, we're saying this is true. If those two things are true, then we have to decide, is the conclusion true? So if the measure of AB is equal to 6 and the measure of BC is equal to 6, then side AB is congruent to side BC. Well, AB is 6 and BC is 6, so they're the same number, so this is also true. Okay, so what we are looking at for this first one is if P, which is our first statement, is true, and Q is true, which is our second statement, then implies Q is true. Okay, so the third statement is true. Okay, then the next time around, on the next row, again we're going to say that P is true. Okay, but this time we're going to say that Q is false. Okay, we're going to say that AB is not congruent to BC. So if P is true and Q is false, then P implies Q is, and that's what we have to determine. So if AB, the measure of AB is 6 and the measure of BC is 6, and we're saying that AB is not congruent to BC, so in other words they're not equal to each other, does that mean that the last part is true? That would be no, because if AB is not equal to BC and we're saying that they're the same number, then AB and BC is false. Okay, so if they're not equal to each other, but yet we were saying that the first statement is true, then this last statement has to be false as well. Okay, there's no case where the first can be true and the second can be false without the third being false. Okay, let's try the next one. On the next one, we're now going to say that the first statement is false. Okay, we're going to say that measure of AB equaling 6 and the measure of BC equaling 6 is false. Okay, that means that measure of AB is equal to something other than 6 and the measure of BC is equal to something other than 6. Okay, but the second statement we're going to say is true. So even though the first AB is equal to something different than 6 and BC is equal to something different than 6, we're saying on the second one that AB is equal to BC still. So when we look at this case, we have to think, is it possible for the second one to be true without the first one being true? So if P is false and Q is true, then P implies Q is. So if we think about this, let's say the measure of AB is equal to 8 and the measure of BC is equal to 8 as well. That second statement is now still true even though the first statement is false. So it doesn't have to be that every case works for this, it just has to be that there is a case that can be true. And since there is a case that can be true, then the final result is also true. So our last statement is we're again going to say that the first statement is false, and now we're going to say that the second statement is false, and we're going to try to see if we can still have a true statement. So this time, if we say the measure of AB is 9 and the measure of BC is 10, now we have two new numbers that are not 6, so it's false because they're not 6, and they're not equal to each other, so the Q statement where they are equal to each other is also false. So can this now be true because there's a case that happens? Yes. So this last part is still true because we have a case where it's not 6 and it's not equal to. That makes this statement still true. So the last one that we did was if P is false and Q is false, then P, the little arrow means implies, Q is true. So the two statements can be false and still have a true conclusion to the whole thing. Alright, with that is how we do the first one. I would like you to try this one on your own. Okay, would like you to fill out the truth table on your own for this question number 6. It says 5, but it's really supposed to be 6. And this says if the measure of an angle is 32 degrees, then the angle is acute. So go ahead, try this one out, and then check to see how you did. So let's look at our truth table here. If P is true, so the measure of the angle is 32, and Q is true, the angle is acute, then the final part is true as well. If the measure of an angle is 32 degrees, then the angle is acute. Okay, those are all facts. For the second part, for the blue ones, if the measure angle of the angle is 32 degrees and the angle is not acute, so we're saying that the angle is either obtuse or right, so then we're saying it's false, right? Then the measure of the angle of an angle is 32 degrees, then the angle is not acute is a false statement, because 32 degrees will always be acute. So that's false. Looking at the third line, if the measure of an angle is not 32 degrees, so it can be anything other than 32, the second part says the angle is acute. Well, are there 32 degree? Are there angles that are not 32 degrees that are still acute? Well, yeah, we could go 31 or 35 or anything less than 90 and still have an acute angle. So the first part can be false, with the second part being true in order to get a true statement at the end. Last one. If the measure, again, is not 32 and the angle is not acute, so it's either 90 or obtuse, well, are there angles that are not 32 that are either 90 degrees, a right angle, or over 90 degrees, an obtuse angle? Well, yeah. So as long as there is at least one true statement that fits the two falses, then the final result is true as well. And with that, that's how we complete truth tables for given statements.